Hey all, so this is the week 2 basic chemistry for investigating living lab walkthrough. Okay, so the instructions are going to be our typical, use the manual. As always, read through everything as first before you start it. It'll just make life easier. You submit the formatted document, and if you add a chart or a graph, make sure it's in the lab. Only one lab document is going to look at, and that will be the formatted lab. You want to see the faculty one, that in your stuff in your dates course will be accurate. It won't say graded, but the original one was really bad, so you get my reformatted one that makes some sense, and then you'll have the rubric and of course the playlist, which is probably what you're watching this through. Okay, let me pause it and then open up. Let's do the rubric first because it's fast, and then we'll go through the long lab doc. Alright, so the rubric is going to be half a point for observations. Each exercise is a quarter point. This time there's 4. Give yourself a lot of time this week to do labs. They take a long time. And then you have the half a point for doing all of the grammar, complete sentences, the lab summary, all that stuff falls over there. So see, nice and fast. So let's open the actual lab. Alright, so title page, it could be nice and enter 3, 4. You create your title page here, so title, name, date, is that right? Title, name, course, date, and my name is optional. See, I remember. Okay, so you'll need to fill in whatever goes in here. You'll say, does it contain protein, yes or no? What was your final color? Did it actually contain the protein? So hypothesis, result, right? And we have page break. As always, if this stuff really bugs you, you can just click on the paragraph and it goes away. Woo. I edit, so that makes me happier. You fill this in, say what you thought the color was if it was actually there. Fill in what you thought, color, if it was actually there. Same thing, what was actually there. And then here, you're going to put a plus if you saw it and a negative if you didn't see it. So did this indicate for protein, sugar, starch, whatever. So you put a plus wherever it did and then a negative wherever it doesn't, right? It just reacts. So let's say the iodine acted for all, then they would all have pluses, and the Sudan did negative for all, that would be negative. You should have, of course, at least probably one thing per one. And if you're not sure, the exercises that tell you what you're testing for will probably tell you which solution you use, and then you can figure it out that way. Alright? So testing for the presence of protein is out. Give me 1 second. I gotta cough a bunch. Okay. So we know it's testing for the presence of protein. So what is the test substance? Probably a substance containing what? What's the title say? I always check the title. The test tube. Which test tube represents the control? So which one do you know doesn't have protein in it? Which test tube had the most? Other than the control, which test tube contained the least? Do the results agree to your hypothesis? In every case, why or why not? What was your conclusion? Excuse me. Apparently my sinuses are acting up this morning. If the color change was not expected, why? Okay, let's see. Let's put in here hypothesize even if it was. So either way, you need to say what could have changed the color, and then you're going to add another 5-drop stir. Did anything happen? Right? Then what's the purpose of this? You know, what were you looking for? This is a discussion. Yeah, what were you looking for and what did you use to look for it? Why is it important to clean droppers and equipment between chemical uses? What other types of food or substances contain high levels of protein? If you're not sure, Google. Just use your in-text citation, right? Suggest a situation where you might use the reagent colorimetric test, and that is my brain is just not on. And then you can use whatever you think might work. If you can come up with something in your mind, or I'll just Google it, or you can, think of a medical purpose, what do you think? And then what other types of analytical procedures detect the presence of protein? Let's face it, I'd have to Google. I just wouldn't know. So I'd Google, use my in-text citation. Easy peasy. Okay, so now we're testing for the presence of starch in cells. So what is the test substance? What are we looking for? Which test tube do we know doesn't have the starch? Which test tube contained the most? Other than the control, what contained the least? You're going to notice it's because you're doing 4 things, they will have very similar questions. Did your results agree? You know, since we had that, why don't we just go up here and copy this? We just did this one. Where were we? Always answer every question. If it didn't happen, you go, well, if it did. Okay, so then what are your conclusions about the results? And if the color change was not as expected, that was it. Oh, I didn't need it here. I needed it in the next one. Ha, I lied. Isn't Control Z wonderful? I love Control Z. It goes here. Alright. We will save. And then what was the purpose of this exercise? So what did you use to test? And what were you testing for? That kind of thing. What other types of foods might have this starch in it? We're still doing starch, right? Yep. And then suggest a situation where you might use the iodine colorimetric test. And what other types of analytical procedures detect for starch? Okay? So if you don't know, or if the lab manual didn't mention it, even if the lab manual mentioned it, you'd probably cite the lab manual. My lizard is so happy and warm. He's all spread out. He's so cute. Okay, focusing. Then we have testing for the presence of sugar. So we're going to be looking for what in cells? And then which one do we know does not have that? And which one has the most? Which one has the least? Did your results agree? What were your conclusions? If the color change was not as you expected, what reasons? And then what's the purpose? So what did you use? What did you find? So was that helpful? Suggest a scenario where you might use the Benedict's reagent colorimetric test. How might one determine whether a potato or an onion has more sugar? I have to scroll down because we went through that pretty fast since we've already done it. Okay, making sure nothing weird. What other types of food might have a lot of sugar? And what other types of analytical procedures detect for the presence of sugars? So now we're for lipids. So what's the test substance? You're looking for what? In what? Which one do you know does not have that? Which one had the most? Which one had the least? Did the results agree with your hypothesis? Was the color change as you expected? Right? It's not really a color change so much with this, but whatever. And then discussion. What was the purpose? What did you use to learn about what? Explain the molecular basis as to why SIDAN3 can be used to detect the presence of lipids but not sugars or proteins. So why are lipids different, basically? What other types of foods or substances have lots of lipids? Remember, lipids are fats. What other types of analytical procedures detect the presence of lipids? And then you fill in your table 5, which was above, right? I would be tempted to read through this whole lab. You know what you're testing for what based on the exercises names and which test you're using, and then to fill in table 5. But make sure if you do that you go back. Well, you can't do it all because you don't know until you test, right? What you found? Yeah, true. There you go. Never mind. I was like, I would be tested. I might be putting like a little, though, like I think it's going to be this one. Well, you do that with the hypothesis, so I guess you're fine. I always think of it all being filled in, but yeah. So I guess do your hypothesis once you read through it, like, oh, which ones do I think? And you fill those other tables. And then table 5, I would fill in after I did everything, and then just do it off of that. Remember, split screen is awesome. And then we have our lab summary, which is what have you learned from doing this lab, and you need at least 3 sentences. If you need a references, do a insert page break. You'd click here, page break, and then that will give you a new page. You can do your references, centered, and then all of those. I would need to, because heck if I know an analytical procedure to detect the presence of lipids. So I would be like, you know what, this is Google time, because in 4 minutes I can find everything and cite it. But it is up to you. as always, and if you know, you know, so it's cool. And I think that's the biggest stuff. I would, as always, recommend that you send me a draft by noon of the due day, and you get your free S post if you post your tables that are completed. It's useful if you do submit a draft, or like say people seem to get really different results, and so you send me a draft, or you know something, like you look up what is albumin, or you know what is the starch level or the lipid level, and you got like none, and you know like oil should have a lot of lipids, then, or your draft, and I tell you like, oh, it should have been this other one, what you'll do is you'll leave your observations the way that you saw them, because that's what you saw, right? So you would still, like, say you didn't see any lipid in oil, and you're like, right? So that tells you that something went wrong, which is fine, and then you would put a note, like, you would say, this is what I saw, but then when you answer the exercise, you're like, you know, it should have been the one that had the most, let's say distilled water had the most, which means something was really wrong. But then you would say, you know, my control should be the water. It showed the most oil. It shouldn't. You know, based on research, other people's data, I know. I say other, especially if other students have submitted, that'd be the easiest. We're just saying, based on, you know, common knowledge and research, it should be the oil. And this is probably due to my results being skewed, which we'll address later, or something like that. And then on the later question marks is like, did something happen that was unexpected? You'd be like, well, oil should have been the most. It wasn't. And this could have gone wrong because, you know, stuff could have been old. I don't know. Blah, blah, blah. Maybe it was too healthy. Maybe they sent me the wrong thing. All sorts of fun stuff. So if you do get weird results, keep them in your data, but like have a note. You can even do, like, some people like to put a note underneath the table and just say, like, you know, something went wrong, the result should have been blah, blah, blah. That's also a very, very nice way of handling it. So just keep that in mind. Like, I still want to see what you saw, but if it's weird, explain it, right? Just don't assume that you're always right, because some of the stuff just goes wonky. And if you, for some reason, nothing works, like if you did get a case where the distilled water actually was the only thing with the result, just ask me if no one else has posted a lab, or just use somebody else's data. You know, it happens. It's fine. Okay, I hope this helped. And send me a draft.